Hi folks, thanks for tuning in. Welcome to booting 8 Kubernetes clusters on every Git push, how Linkerd leveled up its CI. Some of you may have noticed that we just changed the title of this talk from booting 5 clusters to booting 8. In the time that I submitted this talk, we've added more clusters, so we're going to get a little more out of this talk than we originally expected. My name is Andrew Seigner. You can find me online and on GitHub and Twitter at Siggy. I'm a Linkerd maintainer. I'm also a software engineer at Buoyant. So just a quick agenda of what we're going to cover. I'm going to touch initially just on Linkerd. It's kind of an implementation detail of this talk. This talk's really about evolving a build CI system, but it helps to contextualize it by speaking to like what were our specific requirements. Being like an open source project with a relatively small team, it helps like give some context on why we made the technology decisions that we did. Then we get to kind of the core of the talk, take 1, take 2, and take 3, where we go through like 3 iterations of our build CI system. We're going to start with kind of where we were a year and a half ago. It wasn't a great place. And then we'll go through like requirements gathering to rebuild the system, what tech we evaluated, and then we'll look at kind of our 2nd and 3rd generation of CI. And as I alluded to earlier, the 3rd generation is something we just got out, and it happened after this talk was submitted, so that's all bonus. And then at the end, we'll cover lessons learned. So here we go. So just a little bit of background about Linkerd. Linkerd is an open source service mesh. It's a member of the CNCF. I'm not going to get really into like what is service mesh or why you need one. For the sake of this talk, it's just important to know that it's written in Rust, in Go, and in JavaScript, and it runs on a Kubernetes cluster, and it manages all traffic. And it runs as several different deployments, and it injects proxies into all of your pods. So it's really important that we test this thing in a live environment because it's taking over all of your traffic. It's really important that it works. And so testing it very thoroughly on a live Kubernetes cluster is super important, and that motivated a lot of the work that you're going to see. So just to give an overview of what exactly are we testing, for a typical like PR of Linkerd, we have static tests like linting, we have unit tests, and we have a Docker build and integration tests on Kubernetes. And again, that's across like testing like JavaScript, Go, and Rust all at once. We're going to mostly focus on that box in the lower left-hand corner where we're doing a Docker build and then we're running integration tests on a live Kubernetes cluster. So to kind of go back a year and a half ago, where that Docker build and integration test was, we were running our whole CI system on Travis. We were doing our Docker builds on the Travis machine, then we were Docker pushing up to GCR.io, Google Container Registry. And then we were running our integration tests on a GKE cluster. It was like a 3-node cluster. And on that cluster, we would install Linkerd, we would run a bunch of integration tests, and then we would uninstall Linkerd. Pretty quickly, we realized we needed additional tests, and we started running Helm tests as well. So we install it with Helm, run our integration tests, uninstall it with Helm. And then we found we also needed to test our upgrade path. So we install an old version of Linkerd, then we upgrade it, then we run our integration tests, then we uninstall. You can see how quickly this is starting to back up. So now imagine like we want to run 5 or 8 of these kind of integration tests, and we're doing it all on one Kubernetes cluster. Because we're a small open source project, we can't just spin up a whole bunch of Kubernetes clusters like that. And then couple that with like, we have lots of contributors coming into the project. And so it wasn't uncommon for your PR to take an hour or 2 for you to get through CI. That's a really bad place because everybody was sharing this one singleton cluster. So at this point, we kind of took the nuclear option and we pulled our integration tests out of the main like PR flow. We were still running them when we were merging into the main branch. But of course, as soon as you do that, you're going to have PRs that are passing unit tests and like static tests. And as soon as they're merged, they're going to run the integration tests and fail. So now the main branch is failing often because we're not running our integration tests enough. As soon as we hit this point, we thought, wow, we really need to like take a step back and rethink how we're doing this whole setup. And that's what motivated all of this work and this whole talk. And I should call out on that slide, you'll notice like git commit links on the bottom. You'll see that throughout the talk. And so note that everything we're talking about was all done in the open. So you're totally welcome to like click through. And if you want to see like all of the interesting details that I'm totally glossing over in this talk, they're all available to check out. So we really took a step back and we thought like, what are our requirements? And we didn't start with like, we need a new CI system. We started with like, what do we need? What do we care about? And what kind of pain points are we thinking about? And so we kind of came up with this prioritized list. We thought, okay, first off, we want reproducible build and test. And that means that if we see an integration test failing in some automated system, I want to be able to run a command on my laptop and reproduce that exact same environment locally where I can quickly iterate and make code changes and keep running those tests. We wanted a UI to like browse all of the tests that are running. That seems kind of a given for most CI systems, but we were considering like anything. Like, could we have like offline jobs that like kick off as scripts, or could we have things that like comment back on PRs with just like a thumbs up or a thumbs down? But we knew that that was important to be able to like send a link to somebody and say, hey, I need you to look at this, and see what's going on with an integration test failure. We wanted it integrated with our PR workflow. So that means integration with GitHub. We wanted hermetically sealed build and test. That means that, we're taking PRs in from possibly like people that we've never worked with before, maybe forks of the repo. And we didn't want totally untrusted code running on like hardware that we were paying for. And we didn't want to have to deal with like bots where we like approve or disapprove, or we have to like spot check a PR before integration tests get run. So we really wanted a way to like spin up a totally as safe as possible environment and then delete the whole thing when it's all done. We also wanted it to be fast. Again, like things were taking hours. So that meant, not pushing Docker images across the internet for every PR. It meant doing incremental rebuilds, the difference between a cache Docker build that takes 5 minutes and a Docker build from scratch that takes an hour. It's a lot. And we were interested in a remote build. So that meant, can I run a command on my laptop and have all the heavy lifting be done on a remote VM? So the last 2 bullet points were not hard requirements, but they were things we cared about. So being an open source project, we knew we wanted the solution to be at least cheap, preferably free. And we did want to use open source tech for all of this. But if there was a closed source solution that satisfied our requirements, we wouldn't like discount it outright. And you'll kind of see some of that thinking in a minute. So based on all of those requirements, we just kind of surveyed the landscape, or like, what are all the tools in this space that we can use to help? And we weren't looking for one thing, and we weren't looking for like 5. We really didn't know like what combination of tools we would use to build this. So we just kind of looked at each one and built to varying degrees proof of concepts with all of them, just to see like what would be involved. And I want to give a disclaimer. If you work on any of these tools and we didn't select it, please understand this is not like we're not discounting anybody's work. This talk is really about what worked really well for our specific requirements, and everybody's requirements are different. And, that includes like what we were familiar with and how much time we had and how much like money we had in engineering resources and all of that. And so all those factors kind of play in. And with that in mind, I want to talk about one particular piece of tech that we very nearly selected, but didn't. So we spent a lot of time working with Prow. For those of you not familiar, Prow is like the build CI system that the Kubernetes community uses. And that's what really drew us in the first place. We really thought if it's good enough for Kubernetes, it's got to be good enough for us. And we had a fully working end-to-end system. It was open source, huge plus, right? We were building our Docker images on a Prow cluster running on Kubernetes, running all of our integration tests through Prow, and it was all working. What we started to find though was we were looking for a solution that would require basically like zero attention, like at most like 1/10 of one engineer. And it felt like Prow was something that probably required a little more paying attention to day to day, kind of like running a Kubernetes cluster itself, like in production. So we kind of took a step back, and even though I really wanted this to work, just from like a human effort area, we thought maybe we could find something a little bit less labor intensive. So with that in mind, spoiler, here's the 3 pieces of tech we settled on. We selected kind, GitHub Actions, and Packet. And I'm going to go through each one of those and kind of talk about why we selected them. So first off is kind. This was the first one we zeroed in on and kind of decided we wanted to use. For those not familiar, it stands for Kubernetes in Docker. It allows you to spin up a Kubernetes cluster anywhere you're running Docker, and it runs the whole cluster in a single Docker container. Similar to Prow, it's used by the Kubernetes community to test Kubernetes. So the fact that it's used by Kubernetes in CI made it a very compelling case right away. It's very fast to like spin up a cluster and delete it later. And it's really good for local development. You can run it on your laptop. And that was key because that meant that whatever we were going to script and run like up in whatever system we were going to build, it means that I could run exactly the same thing on my laptop and kind of reproduce the entire environment. It also meant that wherever we were doing our Docker builds was where we could run our Kubernetes cluster. So that meant no more pushing Docker images across the internet. And bonus, it was open source. So that was kind of the first piece of tech we zeroed in on. And then we started looking at like what things can we build around this one piece of technology. The next one's a bit of a curveball. We ended up using Packet for bare metal servers to do like very like fast build and like Docker caching and running all of our kind clusters. And the reason we selected them was because they have a partnership with the CNCF that provides free compute to open source CNCF projects. That's huge. So like shout out to them, like to be able to get like a large bare metal machine like that. And to make our, we had our whole build pipeline down to like a couple of minutes, thanks to these clusters. So we're talking like 45 minutes to an hour down to a minute or two. That was pretty awesome. And then the last piece, as we were evaluating Prow, GitHub Actions was just coming like through beta. And we found that we started experimenting it with a little bit, and it had some properties that were really compelling to us. First, it was integrated. It's already in GitHub. And that means one less integration point that we had to be concerned with. It had a feature called matrix builds, which allows you to run a bunch of similar builds based on a parameter. So for example, if you're booting 8 Kubernetes clusters in a slightly different way, you can do that with a matrix build. It has really nice control over how you define the dependencies between your tasks. Maybe I want to boot up a Kubernetes cluster and do a Docker build. And then when both of those are done, I want to run an integration test and then do a release. And their kind of config makes it straightforward to do that. And then it wasn't open source, but it was free for open source projects. So, shout out for that. That kind of sealed it for us. So then we kind of move forward with a full setup with those 3 tech choices. And you can see the lower left has been replaced with using kind, Packet, and GitHub Actions. The whole thing is GitHub Actions now. Note that even though we're doing Docker builds and our kind cluster work on Packet, we're calling it out only for non-forks. So because we were still running hardware that we were responsible for, we didn't want untrusted code running there. So that meant for the maintainers internally, we had this really nice environment, but if you were an external developer just coming into the project and you submitted a PR through a fork of yours, you would be running all of this work on the GitHub Actions boxes. You wouldn't get the advantage of Docker caching. It would be much slower. And that was kind of a bummer. That kind of made like external developers like almost second-class citizens when you're coming in and it's your first experience. We want it to be really positive. And when the CI turnaround is that slow, that's kind of a bummer. So more on that later. And just to kind of illustrate what this matrix configuration is, this is a list of the 8 Kubernetes clusters that we boot up. I'm not going to go through all 8, but just as an example, you'll see that first one says cluster domain. As some of you know, like when you deploy a Kubernetes cluster, all of your services by default, they're named like something.cluster.local, and that's kind of the default cluster domain inside Kubernetes, and you can configure that and change it. And it's really important that Linkerd behaves well if you've changed that default cluster domain. We've definitely committed changes that broke this behavior. So it's really important that we spin up a Kubernetes cluster with a modified cluster domain to confirm that we're continuing to support that configuration. And then you can imagine we've got 7 more configs after that that we're testing all of these different ways. And each one of these is spinning up a kind cluster in parallel, all on that packet host. So next we're going to jump into a demo where you may have noticed in this previous slide where everything's running in GitHub Actions, but the heavy lifting is being done in Packet. And we figured out a way to do that by using a Docker SSH environment variable and some fancy work with how we were using kind. And so we're going to demonstrate building Docker images, creating a Kubernetes cluster and interacting with the Kubernetes cluster, but everything is on a remote machine. And this is something that our GitHub Actions boxes were doing, but it's also something that you could do on your laptop if you don't want to run a kind cluster on your laptop or even run Docker on your laptop. So here we go.
Okay, so we're going to demo creating a kind cluster on a remote VM from my laptop. So here I'm demonstrating that I don't have Docker running on the laptop. I can't connect to anything, but when I set a Docker host environment variable to SSH and then the name of the machine I'm connecting to, I can now connect to Docker and use Docker on that remote machine. Now I'm going to create the kind cluster. We're going to call the cluster kubecon demo. And here's the kind cluster booting up. Now all of this work is being done on the Docker daemon on the remote VM, and the kind cluster is booting up over there. So here it is, it's coming up. Now note that I still can't use kubectl to connect to that cluster just yet, because again, the Kubernetes cluster is running remotely. But what I can do is I can look at the kubectl config, note which port it's running on the remote VM, grab that port, and then I'm going to forward that port from my laptop to the remote VM. And if all work correctly, I can use kubectl to connect to that remote kind cluster just as I would if it was running locally.
Okay, so we just saw like we were able to spin up a Kubernetes cluster somewhere else and run it. This felt a little weird, maybe a little hacky. It's just some kind of bash foo on modifying Kubernetes configs on the fly. So before we went live with this, I checked in the kind channel in Kubernetes Slack just to kind of see if what we were doing was weird or expected, or if people had experience doing this. And so I asked a question, and Ben, the author of kind, responded immediately. So shout out to that community, and particularly the author of kind, for being super helpful and responsive. Makes for a great experience working in open source. And he basically said, well, we didn't really expect anybody to use kind in a remote way like this, but it seems relatively sane, so go for it. And that was nice to hear. That definitely gave us a little bit of confidence that like this wasn't too crazy and we could proceed. And that's what we did, and we went live with the system. Now, fast forward a few months, I had mentioned that using these packet clusters means that we still had to run our forked PRs on the GitHub Actions boxes, and they were slower. We got a little bit of experience with a new Docker tool called Docker buildx, which allows you to take a Docker cache and kind of save it and restore it in a file, which makes it really nice for using it in a CI system like GitHub Actions. So as soon as we got Docker buildx in, it meant that we got all of the benefits of a Docker build cache on GitHub Actions, and we no longer needed the packet host. And that meant that forked PRs and non-forked PRs all got to run at full speed. So next, I'm going to take you through one more demo where it kind of shows everything working together. We're actually going to go from git push to 8 Kubernetes clusters. So here we go.
Okay, so we're going to demo the latest version of our build CI system. So here we've got the Linkerd repo. We've got a PR that's reporting that it's breaking in CI. So we're going to dig in, see what's wrong, and then try to make a fix. So here we see that one of the integration tests has failed. These are kind integration tests that we've been talking about. So we dig in, we notice it's the upgrade test. It's the test that where we install an old version of Linkerd on a Kubernetes cluster, then try to run an upgrade. And as we look through the log, we see that some command called upgrade broken is being run. That seems wrong. So we'll go back into our code. We'll find where that incorrect command is being run, fix it up. It should just be called Linkerd upgrade. And we'll verify the change that we're making, and then commit the change, push it up to GitHub. This is where going from a git push to booting 8 Kubernetes clusters comes from. So now that we've pushed up the change, we should be able to go back into GitHub, click our GitHub Actions tab, the checks tab, and note that the new build has already kicked off. You'll see some of the more simple tests kicking off right away, like the unit tests, the linting, static checks, all that stuff. And then the Docker build is already going in preparation for our more complicated integration tests. I'm going to speed up this whole section of running the integration test because it takes like 10 minutes. We don't need to sit here through that. But note that we're following along on the Linkerd upgrade test, and we're seeing all 8 of those Kubernetes clusters get booted up, and the integration tests run in parallel across all of them. As the tests are wrapping up, we've verified that all the things on the left are showing up as green. And then we should be able to jump back to our pull request and confirm that the build has been fixed. So just in a matter of a few minutes, we're able to make a change and boot up all of those clusters, test it across all those different environments, and we're...
All right, so there you go. That was a git push followed by 8 Kubernetes clusters getting spun up all at once. And that's kind of the culmination of all the work we did. So to think about the lessons learned, 1, use kind. It's a great piece of tech. There's some other good ones too. I know Minikube, K3D, there's a number of flavors. We've just found it super useful. And not just the tech itself, but the community. Having like a friendly, responsive place where you can ask questions makes a huge difference. We try to emulate that working on the Linkerd project too. We found it really encourages a healthy sense of community. Cache your builds, especially your Docker builds. The Docker host SSH pattern is really nice. I haven't run Docker on my laptop in many months. It's great. So I definitely encourage you to check that out. Docker buildx is really nice for caching, and now we're starting to use it to do multi-arc builds. So we're, I believe either today or this week, Linkerd will have ARM builds as it goes out through our normal release workflow. And a big shout out to Packin and GitHub Actions for supporting open source and allowing us to use their infrastructure. And one more thing, something I had really liked about Prow was that it provided this really nice heat map of all of your build statuses. And just recently, one of our Linkerd maintainers, Alejandro, built this dashboard in a similar vein that kind of gives us like a timeline view of like how are we doing over time with our build health. So check this one out as well. The links are all in the slides. So shameless plug for Linkerd. Please come check it out. We use it a lot. Other people use it a lot. We're always available in Slack or say hi at GitHub or wherever. We try to make it really welcoming. And you can always check out like how our GitHub Actions are set up because this is all live and all open source. So with that, thanks a lot. Hi, folks. Thanks for coming to the talk. I've been answering a few of your questions in the Q&A. I think there's a couple more, so I'm happy to answer stuff live as well. So let's see. I see one from Joseph that asks about how the cache with Docker buildx works. I didn't actually implement that. Some other members of our team just did in the last month or two. But if you go to the Linkerd2 repo, and I think there's some links to it even in these slides, but you just Google for Linkerd2 GitHub. All of our GitHub Actions configs are, they're all in the repo. They're all open source. You can watch them running like right now. So I definitely encourage you to just like poke through and see how those jobs are happening. It should be all right there. Anya asked, did you ever notice issues that slip through kind only showed up on real clusters? Yeah, that's absolutely a thing. You can only test so much until you get to like real production. So I think there's definitely a class of like timing and scaling issues that can happen on a Kubernetes cluster that's maybe more fully loaded or, is running in a different environment. So to that end, in addition to running all of the kind jobs for every like merge or every PR, at time of merge into the main branch, I believe we still run our integration tests on a live GKE server. Sometimes that can catch other classes of issues. It's on our roadmap where we would like to be able to run like our integration tests on GKE, on AKS, on EKS, you know, all of the different cloud providers, DigitalOcean, all of them. And we've definitely had issues that have cropped up that only occur on like one cloud provider. And then obviously and that catches one class issues, and then obviously things come up in production that we didn't anticipate. And when we see that, we try to update our integration tests to, you know, catch those type of scenarios. So yeah, there's never like one layer that like catches everything, right? It's all about having like many layers that hopefully they each do their job on catching things. Jack Kelly says, how are you cross-compiling your Rust proxy? I'm actually not sure. If you look in the Linkerd proxy repo, and all this stuff is linked from Linkerd, so if you can just Google for it. The Rust code lives in a separate code repo called Linkerd proxy. You should be able to see how we're building stuff there. Also, I bet if you look in the main Linkerd repo, I think that's where we're generating the Docker image for the proxy. And so you should be able to see in there how we're doing the build. Andre, thanks for coming to the talk. So yeah, so happy to answer anything else. And I'll be around here and in the CNCF Slack. I'm also available online all the time. I'm in Linkerd Slack all the time too. So definitely come say hi if you have questions about this setup or Linkerd in general. Happy to go through things.